Hello everyone. In this tutorial I'm going to be discussing how to generate Gerber files which can be used in milling processes in ADS from designs that you've created either in HFSS or in ADS itself. So I'm going to begin by talking about a design that I've already created in ADS, but if you've created something in HFSS and would like to import it, you simply go to File, Import, and then you have a list of file types that you can choose. Simply choose DXF if you've done a DXF file export from a program like HFSS, and then browse and find the file. But let's assume that instead we used ADS Momentum to generate the layout. The process is going to be almost exactly the same, except there's a couple of extra steps if you're starting from an ADS simulation. So the first thing we're going to want to do is in ADS you need to simulate using ports. So we're going to delete those ports, and what you're left with is just the conductor layer. This also applies to multi-layer designs. You can do the same or a very similar process for multi-layer designs. But for now, we'll just talk about if you have one layer. So the first thing I like to do is go ahead and unite all of the top layer, the conductor, because right now I'm using multiple different types of elements to form the patch. So we're going to go ahead and just hit Edit, Merge, Union, or you could do Shift U alternatively. And then the next thing I like to do is get an idea of the footprint of the connectors that I will be adding to the design. So in this case, we're going to be using these SMA connectors that I'll attach a picture to in the video, which have 4 holes that'll add some structural support for the SMA connector. And then it has a pin in the middle which goes through the ground plane of the board. So let's go ahead and add that footprint. So the footprint's basically going to consist of 4 circles. So we'll select conductor layer, and we'll select the circle drawing tool and just draw some circle. Click on it. And the radius of these, basically these are going to be my structural pads. This is going to be 90 mils. Okay. And the spacing here between the various pads is going to be 338.6 mils. So for simplicity, let's just choose some random layer like default and draw a box. I'm going to turn on, these snap tools are extremely useful. So you enable snap with this button, and I'm just going to turn on a center snap. I'm even going to turn off grid snap here. So basically that snaps me right to the middle of that circle, right? So I'm going to draw some random box size, and the width and height will both have 338.6 mils. 338.6 mils. Okay, and if you need to move your box, just press the letter M on your keyboard, turn on corner snap here, bang, and then let it snap to the center of the circle. Okay, now we're going to copy this pad on all 4 sides of the square here. So to copy, you hit the letter C, click, do it again, once more. Okay, so these are basically going to form the pads of the connector here. I'm going to go ahead and turn on this key showing program. Okay, so now we've got the pads. Let's go ahead and add the holes. So to add a drilling layer, you're going to go to layer hole, and the size of the holes that we need in order to match the SMA connector have a radius of 40 mil. Just go ahead and snap there, select the hole, 40, copy it. Great. Okay, so there's our basic layout for the connector support. And then the final thing is we basically need, the center of the connector goes through the board here. So what we'll do is, let's see, this is going to be basically all of this stuff here is going to be placed right on the end of this line. So it's kind of going to give us a sense of how long this line needs to be as well. So let's see. I want the connector to be somewhere, let's see, somewhere around here. Be a little closer so I can print a few on one board. So somewhere around here. So the first thing I'm going to do is actually move this edge here. You can select this object. Now I can control this edge. I'm going to turn on midpoint snap. Actually, I don't even really need that. I just need to snap it to the midpoint of this rectangle. So if I drag, bang, you see it snaps to the midpoint. And then I need this. Oops, I don't want to select these two. Oops. Let me undo that. So actually, I'll just select these two. Select the. That's not a good strategy. Actually, I'll undo. Move this roughly where I want to, like this. Snap the center like that. Then select like this. And then snap it to the center. Oh, I need to turn on center snap. There. Okay. So now the connector is sort of snapped to the end of this transmission line. Okay. So the next thing we want to do is sort of add a little circular. We want to round off the edge of this transmission line. So I'm just going to take these two and unite them. Shift U. Okay. And we need to add a hole for the center pin that's going to go right in the center of that line. Okay, and the radius of that for this particular connector is 25 mils. Okay. So now that we've done that, I'm going to try to center the patch in the middle of our board. So the board cutouts that I'll be creating are going to be roughly 5 inches by 6 inches, 5 inches in width and 6 inches in height here. So first thing I like to do is sort of create a dummy box around the patch. Sort of basically just around the area that I'm going to want to center inside my bounding area. So I want this green region to be centered inside of the box that I'm about to create. So let's create bound. Oops, that's bond. Bound. Let's create a new square here. Let's make it 5 inches, which is 5,000 mil, by 6 inches, 6,000 mil. And let's just turn on center snap mode. Might even be easier if we move this over here for a second. Let's let it find the center. And then over here do the same thing. There it is. Okay. And actually I'm going to do 550 mil. If I can get as much far away from the edge of the patch as possible. Great. Okay. And if I just for convenience, I'm going to move the center of this whole design to the grid. So I want to move it to that position right there. Okay. Now I'll delete this and delete this box. Great. So this is going to be the final patch. The next thing that we need to do is add the rub out area for the connector on the bottom, because otherwise it's just going to be a bunch of copper that it connects to, and we need there to be some dielectric exposed beneath this layer. So we're going to go to, it doesn't really matter what layer, you can sort of define these in the milling process at a later stage. You can also add layers if you feel like, but oftentimes it's just as easy to use the default layers in ADS. So I'm going to go to Con 2, go here, and make this radius 83. Okay. And this is all that you really need for the patch design. You know, we've got our connector set up here. We've got our patch out on this side. The rest is basically going to be focused on the actual fabrication process. It's going to be specific to the fab process. So for the milling machine that we're going to be using, it's going to be a lot easier on the milling machine if we limit the area that the drill has to route. We don't want the drill to be rubbing out all of this area, or else we're going to go through the drill bits really quickly. So what we're going to do is sort of create a rub out region. So we'll start by creating a box. Let's make let's add a layer here. Maybe we'll use bond, for example. And we'll turn on edge snap mode. Don't really like the way that one looks. So in this case, I think I actually will add a layer for the rub out region. So I'm going to delete that. Whoa. What I just did there. Okay. I'm going to go to Options, Technology, Layer Definitions, and we're going to add a layer. We'll call it the rub out top. And this is a bounding area. Hit apply. Okay. Let's find that layer up here, about top. Hopefully the color is kind of nice. I don't really like that color, so we'll click over here. We're going to make it just outlined. Click OK. And now we're going to add a box like this. Very good. Okay, and we're going to add roughly 1/8 of an inch all the way around for the rub out. So what we'll do, that's 125 mil. So if we're seeing here roughly 3,500 for the width, then we're going to make that about 3,750 or just 3,800 will be fine. So we'll stick with that, 3,800. And then the height, again, we'll just basically add 200 to this. So that's going to be 4,500 roughly. Okay. And then we're going to lock that to the center. Oh wait, let's see, that's just one. I just added 1/8 of an inch to one side for that. So maybe make this 3,900 or so. And the height, 4,600 or so. There's the middle. Oops. So I want to snap it to the edge, or to the middle of my patch here. So I'm going to add again some dummy shape that I can snap to. Turn off grid snap and edge snap. Center snap. There it is. Okay. So now I can delete this. Okay. And at the end we're going to unite two rub out areas. So okay. Now let's add rub out top, just for simplicity. And again, this doesn't have to be exact, so you can sort of eyeball it. So we're looking at about 800. This would be minus 400. We want it to go, let's just snap it somewhere, turn edge snap on, go here, and then let's turn on grid snap and go to about here. Okay, so this is basically going to be the region that we rub out. If we take this shape and this shape, Shift U, we unite them. This is the area that the milling machine is actually going to cut out, and then the rest I'm going to peel away with a razor blade. Okay, so the final step here is going to be to add some what was called fiducial holes. So you see here that we've basically got a two-layer design, even though it's very simple. We need to do some rubbing out on the back, and then we have to do milling on the top, which means that the milling machine has to do some alignment. And this can be done by adding what are called fiducial holes to your design. And these designs, basically the milling machine can find those holes and reorient the coordinate system when it's milling in order to align the two sides of the board. So I'm going to place these fiducial holes, 4 of them, around the corners of the board. We'll do it ½ an inch away from each edge. So we'll add some dummy box again. Let's do it like this. And make it 500 in width. That's ½ an inch, 500 in height. And right there at that corner, we're going to add a fiducial. And these fiducials for LPKF milling machines need to be 1.5 millimeters in diameter, or 40 mils in radius. 30 mils in radius. So we're going to go to hole, snap it there. And this needs to be 30 mils in radius. So pretty small. And then I'm just going to copy, snap it there, snap it there, snap it there. Okay, so then we can delete these little squares here around the sides, and these are fiducial holes. So the final step penultimate step is going to be to explode this box, because right now it's basically just a layer which covers the entire design. It's not critical to do this step. The LPKF milling machine can handle it if you don't do this step, but it does make selecting objects inside easier. So we're going to go ahead and right click this bounding box, click modify, explode, and now it's like you have individual segments around your design. So like if you click here, it's not going to select this, or if I click here, it selects the patch and not the bounding box. Okay, so finally we're at the export stage. So to do that, we're going to go File, Export. Pretty much everybody uses Gerber files. We're going to check out the options here. I like to use inches just because that's what's comfortable for me. You can choose millimeters if you like. Just want to check that all the layers that you actually want to export are being exported. That looks pretty good. And then yes. So here we see that the whole layer by default is not being exported as a drill file. So you need to check this box to export this as a whole. Okay. So with that, we're all done. And I like to click this View File After Export to see how we did. So click OK. Comes up. Aha! See that So this is the issue with not doing the explode, is it just covers your whole design. Again, the milling machine doesn't really have a problem with that, but let's go ahead and explode it. Modify, explode. So now we've exploded this as well. Now we go File, Export. The options stay the same once you do one export. Click OK. It's going to replace the Gerbers. And there we have it. So if we look at the layers, rub out top, you see that just is a little square around the patch. The whole layer is here. The drill file is the same as the whole layer. The conductor 2, that's the backside rub out area. You see that it's right in the center as we expect, and then the bounding box is just around the entire design. And by default, this usually saves the files, the Gerber files. It'll tell you where it saved it if you do the file preview. But you see that it's going to be in whatever directory that you're working in, manufacturing, then the name of the file, Gerber, and then you'll have your Gerber files. Okay, so with that concludes the tutorial. I hope you found this helpful.